Yeah, now we are going to look into some programming guidelines. These are suggestions. There are other programming guidelines for structured text programming. We're only doing structured text programming. There are other guidelines, Siemens, they have guidelines. And then, so if you don't have any guidelines, use those. These are just some guidelines that are going to be used here in this way of programming PLC, or the way I'm doing it, basically. Let's see. Yeah. Was programming guidelines? Yes. Yeah. It's function blocks that we're talking about. When to use those? It's just guidelines. Functions doesn't have static memory, so there's 1 + 1 is 2. And here are the classes you want to program. Source files, you can't read those. Siemens uses something called Simatic ML, which you can't read, but you can export them, and then you can read the program. Then it would look something like this. These are properties for your FC and FB, it will look like that. And you should have in your heading after the first part of your program, you should tell something, version stuff, and so on. And now how does the program control? Yeah, here is some guidelines further down. Program English language only, no local dialects or accents or whatever. Set it up. Operand symbolic, no absolute addresses. Tag information, just hide it. We don't need it. We have stored it. We don't care. Use define in Pascal, and you get a capital if and a lowercase f. Left align, don't do it. This extend the status information that has, that's for debugging and so on. Error limits, you can check those. Don't do it, because if you are messing around outside your error you have declared, there's an error in your program, your CPU might as well stop, because you don't know what's going to happen next. And these enable output, that's for ladder and FBD program. Of course, we are not programming ladder and FBD. So that, and this is just the colors in your editor and so on. It looks roughly like Visual Studio. And if you could use the default, I don't know if they've changed it, but originally the default looked like some kind of street in Amsterdam that you could run into. And here we use tabs, no spaces instead of tabs, because what we talked about, you need a good editor, because the Portal structured text editor, the SCL editor, is not particularly good. And maybe then the tabs, there is not a line as TR Portal does it, and then it's just looking like a mess when you copy and paste it into an editor to do some quick editing to save money and time. And here's the naming. There are some down here, input and output, there's a separate norm here that's shown. Static naming is how to name it. Capital S start, temporal capital T. It's important to distinguish between temporal and statics. Complex, then of course we don't have the type after the integer that we have used here. Then we have just a static or temp. Function block is a data type in itself, and has to be declared in the static section if you want to inherit this functionality, and then it should start with an S. A constant with a C, and global, if you don't use them, but if you have to, just name them like this. This is some programming guidelines. Of course, now we won't see this data, but absolute addresses or memory address or something, don't use them. Use name. Here's an indicator that you write to once and use everywhere else in the program. And they could be M00 memory bit byte 0 and bit 0 in that. How to program? Initialize whatever you want to use. Validate all your input. If there's input that has to be between 0 and 100, make sure it's between 0 and 100. And if they're not, write it back or tell the user of the program, okay, hey, this one is outside the area. Okay, do whatever you want to do in your program. Write to the outputs. Let's say what you produce from. No, we have to write to that at the end. Try to. And this HMI stuff handling. If you want to compress the bools into double words, the binary data types, do whatever on the end when you're done. Yeah, and general program guidelines, one statement, of course, per line, and a comment after here if you need it. Like this. Yeah, use parentheses. Because here it might be that it does the division, which would of course end up with 0 if the integers first, and then it adds. So if you want to do this, just use the parentheses and make it robust. Declaration styles. Yeah, this is for the constant declarations, but here, for example, for constants, here we have grouped them. The constants are grouped. Comment and blank spaces, use it so it's easy to read your program. Also, yeah, don't comment on 1 + 1 = 2. What's obvious, what you can expect a program of structured text or SCL to know, don't comment it. And if you have to comment everything, you know, the one person reading it, maybe you shouldn't program any text too. Yeah, document preceding the code inputs and outputs and so on. Yeah, so what you should comment, at least assumptions and non-portable codes. Things that are Siemens specific, usually using further function in the CPU, you don't comment, this is a Siemens specific. Jumps, never, enough said. Complex, if you nest cases and if states, maybe you should consider rewriting the code. So if you nest more than 3 levels, maybe you should look at this. Use case statement whenever, because it forces you to organize your program. And the case in structured text does not need a break, so you can't do fancy programming here just to kind of fint out there's people reading your program and try to sideline them automatically so they don't understand anything. We don't do it. We use a sledge when we program. Easy to read, easy to maintain. Block indentation, of course, if this would have been Python, it would be required, but do it. 4 spaces, typical one. Looks nice. Calling subfunction, do it like this. Here's the function. Reason why you have these goose marks here is that there can be spaces in the names there, but we never use spaces in any names, of course. Like this, and then when we inherit these function blocks, we talked a little about you should mark them in the static. These are statics, and has to be, and here is some just handling, whatever. And you can do it like this, that you put arguments in the parentheses, and then you could just assign the outputs like this. And the reason why now in newer systems you get an arrow indicating this variable is actually an output. This is done to make sure it's an output because it's always assigning to the left. And you can do also sfilter.x equals try in front of that, and just call this sfilter with a start parenthesis and end parenthesis and no arguments. It is a possibility. Timing, here's how to do timing. It's some examples down here how to do it. And here, this time tick, it's a function that reads the operating system time tick, so it's pretty precise. It can only time for 24 days and something, but it's usually good enough in control. And Siemens comes from 0 to maximum, so of course this stuff here can be negative, and if it's negative, then you have to wrap it around to get the correct time value. You can do this trick with, let's say, numbers between 0 and 10, and see a wrap when it wraps from 9, when you say 9, and wraps to 0, and then you see by adding 10, you get the correct time. So you can do it for yourself. If you forget this stuff, you're in trouble, deep trouble. Okay. And there is another, that was the time tick, and we are using a project down here which has a long time tick, which is the number of nanoseconds in 64-bit from 1st of January 1990, and it's going to count long enough for this program not to be of any use anymore. We're probably going to be 1,000 years old or something. And how to do it. Then you don't need to care about this wrap because it doesn't wrap. Binary edge test, important. There are embedded functions or firmware functions for edge testing. Don't use those because if you want to port your code, it's probably not the same function in another system. So here's an edge test, a positive edge test. Do it like this. Keep the code, these two lines, keep them next to each other. Because if you forgot this saving or comment it out when testing a program or deleting it somewhere down in the program, this is not going to work. You just keep them collected. And you can, this is exclusive OR. And you can also do it for all the bit types. Yes, for a byte, but you can do this edge test for as many as 64 bits then stored in a byte. It's the same code. And here we use bit slicing to get out. There should probably be % in here for the bit slicing. So you get out the 0 bit here. So you can use bit slicing. Also, looping, we have these. Use 4 because it times out automatically. You don't get endless loops. They can be long, but they are not endless. You get endless loop for while and repeat, and then your CPU is going to stop, and that's not nice. Use finite states whenever possible. If you get a lot of memory elements, let's say I need a couple of flip-flops and something to store something in my program, with 10 flip-flops, write a state machine, because then the memory is in the state and not in all these memory elements that you have. These set reset flip-flops and combinatory logic, they cause a lot of problem. Get rid of those. Use state machines. Here's a little now. Program UDTs. It does show how to program, but it's a collection of basic database. We can nest UDTs to call them type or UDT. DBs, they are two types, data block or instance data block. Revision track, keep this, or make you a revision track of your system. This heading revision by Siemens, it's not good enough. Whatever. Then as an option, if you have a documentation robot for source files, you can look at this robot and see what does it require to make some automatic documentation. And then you have the documentation in your program, only one place. So you don't have to maintain documentation several places. Okay, then it was the functionality included in the template project. We are not going to look at this in this video, but we are going to jump down to this structured text Hungarian notation. Here is also something with this PLC open norm and something that what you could use instead of those if you want to use this pass naming convention instead of this for embedded function. But here is what it is. Static temp global constant global constant, then input image IQ and input output IQ. This is for functions, input output image, but it can also be for your input to your function or something like that if you use that naming convention. And then data types here are some. Any is, you can't use that anymore. Pointer, of course, we don't use, and the complex is here. And here are some examples. We don't indicate arrays, that they are arrays. This indicates that we have got arrays. So the arrays are either static or complex or input or whatever. And it is, this function block, inheritance or multi-instance, as it's called. And what we can do now is we can use this derived naming concept. If we have input Rx, we're going to look at that a little quickly later. So then it's a static that has something to do with this Rx and a temporary that has something to do with this Rx. Of course, this would be an edge detection for a reset input, which this one is called. So then you can use, by using this, then you can kind of look at the variable and say, okay, it has to do something with this input or something with this, whatever. So here is this naming convention for terminal codes. That's the input and outputs from function blocks and so on. If you have let's say a sub-function block of function that you inherit, it's not going to be used standalone in your program, for instance in CFC. or if you use ladder, whatever, then they should be short. They should be abbreviated, just like in PNID diagrams or naming there for instruments and so on. So here are some, just an example. I'm just going to use an example. I think it's down here. XGH, external reference G height, or external position height, or whatever you have, to control object in its active states. Okay. Where did it come from? External input. Okay, it's an input to my function block. Nice. G, position. Okay, position. High. Okay, so my input, which is basically what I'm controlling in the process, it is an external input to me, and it's in position high. What is high? Yeah, it's active. A motor is running and a valve is open. And the one opposite is low, then it's passive. Here's something I put in. That could be nice to have. What else do we have here? Now we could look at an output. There is, with this external input high, is something called binary status conformed high, which means I control it to high state, and actually I have feedback indicating it is in high state. Nice. It's controlled to high. It is high. Nice. My program works. It is high. I haven't controlled it. Maybe it's a feedback error. Maybe somebody has switched it to high state. I don't know. Something bad has happened. Where did this come from? BCH. Binary status. Yes. So binary output. Nice. C. Confirmed. Okay, nice. High. We have seen before. High. It's binary and it's confirmed. It's high. It's actually running. My motor is active running. So you can have a look at it. Yeah. This ICPAS norm, you can get hold of those in Switzerland, and it's expensive. Cost you money. This naming system you can get a hold of because there's an old Norwegian norm called NORSOC, and those are probably available somewhere else, maybe for a lower price. I think Standard Norway, the Norwegian standardization organization, they have that available for a nice price. So, okay, now we looked into a little about programming, what we call robust programming. There's a lot more to programming than this, but these are some highlights. What's important is naming. You get tooltips text in your program just by hovering over your variable. But you can't do if you have 50 variables. It's better to say, okay, this is static, it is an integer. Okay, I need to convert it to a real, because I have to divide by something. I don't want to end up with just 0 and I'm dividing this number with another integer. It's nice to know the data type. And of course, it's nice to know what you can do with a data type. An integer, I can add a Boolean. Well, maybe I can add them, I don't know, but usually I use and or and not on the Boolean types. So that's about that. And then talk a little about final state machine. Try to use a case statement wherever for a memory element. Of course, a case can be substituted with an if statement, but we have the case statement. It's analogous to a switch statement in other programming language, and it has an automatic break. It's forcing you to, let's say, block your program or structure your program, which is important because, especially in PLCs, because these programs, they're going to execute maybe for 20 years. And after 20 years, someone wants to make a change to your program. And it's just a mess. It's expensive. The customer is paying usually. So, but maybe it's not going to call you the next time, especially if it's going to make a new plant. It's not going to use you because you are so expensive, because you need to spend a week to find out what your program is doing. So just help people reading the program. And here is just a structured way of doing it with some suggestions and so on.